Hello viewers. In today's class we are going to discuss another important problem from differentiability of functions, right? So in this session we are going to examine the differentiability of this function f of x at x is equal to 1, right? And here f of x is defined as a sine of pi x for all values of x less than or equal to 1, and f of x is defined as greatest integer of 1 minus x for all values of x greater than 1, right? So let us start, and here what we will do to check the differentiability of a function at some particular point. What we usually do, we find out the right hand derivative and the left hand derivative of the function at the given point, right? And if the right hand derivative and the left hand derivative both exist and are finite and equal, then we can claim that the given function is differentiable at the given point, right? So let us find out the left hand derivative of this function at x is equal to 1. So the left hand derivative is defined as the limit h tends to 0. We have f of a minus h minus f of a divided by minus h, right? And h is a positive quantity and it is greater than 0, and here this point a is equal to 1, right? So the left hand derivative of this function at this point a is equal to 1 is given by this limit. So we have limit h tends to 0 f of 1 minus h minus f of 1 divided by minus h, right? Now f of 1 is equal to sine of pi times 1, because the function is defined as sine of pi x when x is less than or equal to 1. So f of 1 can be obtained by taking x is equal to 1. So we have sine of pi that is equal to 0. So sine 180 degrees is equal to 0. So here we have limit h tends to 0 f of 1 minus h minus 0 divided by minus h. So we have limit h tends to 0 f of 1 minus h uh, can be written with the help of this function, because 1 minus h is less than 1, right? And the function is defined as sine pi x for x less than 1, right? So we have sine pi times, and here we have 1 minus h for x is equal to 1 minus h divided by minus h. Now let us evaluate this limit. So we have limit h tends to 0. We have sine pi minus pi h, multiplying these two quantities by pi, we have minus h. Now here I will make use of one important result from trigonometry, that is the sine of pi minus theta is equal to sine theta, right? So we have limit h tends to 0, sine pi minus pi h is equal to sine of pi h divided by minus h, right? So now what we will do, here we have limit h tends to 0. Now we can write this as sine pi h over pi h, and here we can multiply this quantity by pi, so that pi and pi get cancelled, and here we have the negative sign, so we can write minus 1, right? So now see, this limit is equal to 1, because we know that limit theta tends to 0, sine theta over theta is equal to 1, and here we have theta is equal to pi h, and here we have h tends to 0. So when h tends to 0, then obviously pi h tends to 0, right? So the value of this limit is equal to 1. So we have 1 times pi over minus 1, that is equal to minus pi, right? So the left hand derivative of this function at a is equal to 1 is equal to minus pi, right? Now let us find out the right hand derivative of this function at a is equal to 1. So now the right hand derivative is defined as limit h tends to 0 f of a plus h minus f of a divided by h, right? So this is the definition of right hand derivative, and right hand derivative is also denoted by this symbol, that is r f prime of a. So here the point is x is equal to a, right? So now see, here this point a is equal to 1. So we have 1. So now we have limit h tends to 0 f of 1 plus h minus f of 1 divided by h, right? Okay, so now see, when we have to find out the right hand derivative of the function f of x at a is equal to 1, here we have a is equal to 1, right? And for all values of x greater than 1, the function is defined like that is greatest integer of 1 minus x. So f of 1 plus h, because 1 plus h is greater than 1, right? So we have to use this form of the function for x greater than 1. And remember here h is an infinitesimally very small quantity, and it is greater than 0 but less than 1, right? So we have now limit h tends to 0 f of 1 plus h can be obtained by replacing x by 1 plus h. So we have greatest integer of 1 minus 1 plus h, and then we have f of 1, right? So to get the value of f of 1, we'll take this form of the function, because f of x is defined for all values of x less than 1 or equal to 1 as the sine of pi x, right? So f of 1 is the sine of pi times 1. So we have sine pi is 0, right? So here we have 0 and here we have h, and now we can simplify this expression. We have limit h tends to 0, and here we have greatest integer of 1 minus h divided by h. So limit h tends to 0, 1 and 1 get cancelled, and we are left with greatest integer of minus h, right, and divided by h. So now see, here we have greatest integer of minus h. Now h is a very small quantity, right? And h is greater than 0, so minus h is less than 0, right? And here we have 0, and here we have, say, minus 1, right? And minus h, it lies between minus 1 and 0, because see, h is greater than 0 but less than 1. So if we multiply this inequality throughout by minus 1, what we will get? We'll get 0. The direction of the inequality get reversed, so we have minus h, and here we have minus 1, right? So we can write minus 1, then we have minus h, then we have 0. So minus h, it lies between minus 1 and 0. So the greatest integer of minus h should be equal to minus 1 by the definition of greatest integer function. So this quantity is minus 1. So we have limit h tends to 0 minus 1 over h, right? So now we can easily see that when h tends to 0, 1 over h tends to infinity, right? So we can easily see that this limit is not defined, right? So the right hand derivative of this function f of x at a is equal to 1 is not defined. it implies that the right hand derivative is not finite. So, viewers, from this discussion, we have seen that the right hand derivative of the function f of x at x is equal to 1, it is not defined, right? It means it is not finite. And the left hand derivative of the function f of x at a is equal to 1, it is equal to minus pi, right? And this is a finite quantity, right? So now from the definition of derivability of a function at a given point, the right hand derivative should be equal to the left hand derivative, and both the derivatives should be finite, right? But here the right hand derivative is not finite, it is not defined, and the left hand derivative is finite and it is equal to minus pi. So we can claim that the function f of x, this function is not differentiable at x is equal to 1, right? Because the right hand derivative is not defined and the left hand derivative is finite and it is equal to minus pi, right? So both the derivatives are not equal to each other. So this function is not differentiable at x is equal to 1.